Assalamu alaikum. So in our last five lecture, we were discussing about different types of joins, and then we discussed about the group by clause, and then we discussed about uh, using having clause with the group by clause. So the main purpose of using group by clause was to actually calculate the aggregates along the different columns. Actually, the aggregates in different categories of the column. Like we discussed that we can actually sum up employees by department uh, uh, in an employees table. Let's say we want to sum the salary of employees by department, so we can do it using group by clause. We in lecture 15 we discussed about the cube clause. So why we discuss about the cube clause? Because we know that when we talk about ROLAP, we have facts and dimensions inside that. The dimensions are actually the descriptive measures that actually explains the data or actually explains the facts. Let's say we talk about sales. So sales is a numeric value, but sales is actually described in terms of its dimensions. Let's say we have a company of video rental service and a video sales service. Let's say we have a company that deals in movies, and the movies can be rented and the movies can be sold. So based upon these two departments, we can actually calculate the sales. Let's say we say that in year 1996, our video rental department has this number of sales in this region. So the sales values actually comprised of three dimensions. These three dimensions are time. These the other dimension is region, and the third dimension is department. So we can add more dimensions to actually explain a fact. So it means that a fact can be described in terms of its dimensions. So dimensions are actually the descriptive measure that actually explains the numerical measure, which is a fact. So uh, let's say we have five dimensions inside our data warehouse, and we want to actually calculate the sales upon these dimensions. Now if we look at a single dimension, let's say we talk about time. So if we talk about a time dimension, in time we have multiple other columns or multiple hierarchies in time. Let's say we discussed the main hierarchy of time dimension is all times. Let's say from start our business to date. Now the other hierarchy inside all the times is year. Another hierarchy inside year is let's say quarter. Inside quarter we have month. Inside month we have week. Inside week we can have days. So it means that in a dimension there are number of hierarchies available inside a single dimension. So in a data warehouse, when we talk about sales, we can actually want to get the sales according to an year, according to quarters, according to all the days inside an year. So it means that we want to actually calculate the sales based upon any hierarchy of a single dimension. And in some cases we have to actually combine the dimensions to get the results. Let's say we want to say that I want to see the sales inside central region. You see, now region is one dimension, and the region, inside the region we have let's say region name is one hierarchy inside dimension. And our query is the company CEO wants to get the sales of a region, let's say central region, inside each quarter of an year. So let's say we talk about an year 1996, and there are four quarters inside an year. So he can get the CEO can get the sales of central region in four quarters. So it will get four sales value because we have four quarters inside an year. And we can change the query in a way that we can say that the CEO want to get the sales of a central region for all the months of an year. So now if we look at the query has changed from in time dimension. In time dimension, we move from the quarters uh, to the months. Now we are getting more deeper inside the time hierarchy. Similarly, we can also say that the CEO wants to get the sales of each region. Now he wants to get the sales of all regions inside a country in all the months of year 1996. So now the query has will get more results from the data warehouse. Now let's say we have 4 regions and we have 12 months. So for 4 regions, so for each region we will get 12 values. So for four regions we will get 12 into 4, which is 48 values. So it means let's say we have 4 regions: central, west, east, and south. These are 4 regions, and for each region we want to get the sales for each month of an year 1996. So we'll get 12 values for each region for a video rental department. So it means that our when our dimensions grow and when we want to combine the dimensions to get a facts value, we will get bigger summary tables. So we took actually we looked in the lecture 15 that if we want to calculate all these values, we have to write different or separate queries to get all the results. But we can avoid that situation using the cube clause inside SQL, which was provided in Oracle 12c. Cube clause can be used in combination with the group by clause. Now in our last lectures we discussed about the group by clause. So group by clause is used to actually calculate the aggregates based upon the categories inside a column. Now when we talk about cube, so cube can be applied on columns or on dimensions or from which we want to get the sales. In this lecture we will take a look at a single example of the cube. How can we use the cube and how can we actually get the data? How can we get all the summaries from a single cube statement from all the 3 dimensions? We will use 3 dimensions inside our example and 1 fact to actually calculate all the summary that we can get from a cube clause. So let's start our lecture using cubes. So if we look at the example, so we have 3 dimensions here: time, in which we will use year column, which has values 1996 and 1997. We have region dimension, in which we have a column region which has only 3 values: central, east, and west. And the third dimension is department, in which we have department name, video rental, and video sales. Now if we look at these dimensions, we can only consider that time has only one hierarchy, which is year; region has only one hierarchy, which is region name; and department has only one hierarchy, which is department name. So in these dimensions, in these hierarchies, we have only 2 similar some little values. So in year, in dimension time, we can alternatively use dimension as a table, and so time dimension or time table has only one column or only one hierarchy, which has a value 1996 and 1997. So region dimension or region table has only single hierarchy or a single column, which is region name, which has 3 values: central, east, west. Now our department dimension or department table has one column, which is department name, which has only 2 values: video rental or video sales. So we have 3 dimensions, and we have a fact table whose name is sales, and it has a foreign key of time ID, which is coming from time dimension. A region ID is a foreign key which is coming from region dimension. Department ID is a dimension is a foreign key that is coming from department dimension. And we have a sales value. So it means if we want to get the sales, we can get the sales according to the time, region, and this department. It means we can similarly say that that we can know the sales of a department inside a region, inside some specific time. So fact table is actually showing us that we can actually get the sales of a department from a specific region and from a specific time. Now using these four tables, actually 3 dimension and one fact table, we can actually calculate all the summaries based upon these dimension based and using the cube clause. Now if we take a look at this query, what are we saying? So select, let's take a look from on the from clause. So in from clause we are taking these 3 dimension, actually 3 dimensional fact table to query. So time, which has an alias of T, department has an alias of D, region has an alias of R, and sales has an alias of S. Now we discuss in join when we have more than 2 tables. So let's say we have n tables in our from clause, so we need n minus 1 join conditions to actually calculate, get the accurate join result. So in this case we can have so we can say that S is for sales, so for sales region ID, which is a foreign key inside sales, is equal to R dot region ID, and S dot department ID, which is a sales department ID, and is equal to D dot department ID. And similarly for time we have, now what we are doing here, and let's go to select statement. What we want to get, so from time we want to get the year column, from region we want to get the region column, and from department name, so from department we want to get the department name, and what we want to get, sum of sales from the sales fact table. And so we discuss in when we were discussing about group, so we need to actually provide the column names inside group by clause, those columns that we are using inside a select statement to actually categorize the, or actually get the aggregates from the categories of these values from these columns. So we know that in year column we have only 2 values, 1996 and 1997, but this T is actually a foreign key inside sales. So there are multiple values of 1996 and 1997 in our fact table. So in region we have 3 values, and similarly this table is also referring inside sales. So these 3 region names will be referred more times inside sales table. Similarly these 2 departments are also being referred inside our fact table. So these department names will also be given inside, actually referred inside our sales table. Now the sum is being calculated based upon these 3 columns hierarchies or column values. There are no hierarchies inside a column, but there are different values based upon this we can actually calculate all the results. So in our group by clause we provided year, region, and department name. These are those columns that are being provided in the select statement, and outer of these 3 columns we provided it with the cube. Now in our result we'll see what the group clause does, but we can only say at this point that this select statement is actually calculate the sales based upon the year, region, and department name inside our fact table. Now if we take a look at the result, we will see, so I already discussed this. In time we have, or in year we have 2 values, 1996 and 1997. In region we have 3 values, central, east, and west region. In department we have 2 departments, video rental and video sales, and in our sales department we have actually the sales according to these terms. Now what it gives us, this is the year column, this is the region column, this is the department name column, and this is the sales column. So now if we look at the first row, it is saying that in year 1996 in the central region, video department has this number of, so this number of profit. So it has 75,000 profit for department video rental in central region in 1996. Similarly, the second row is saying that in year 1996, the central region video sales department had this number of sales, or this department got earned this number of profit in central region in 1996. Now, if we take a look at these two rows, there is only one difference. This profit is for department video rental in central region in 1996, but in this row, this profit is for department video sales, not for video rental, in region central and 1996. So it is saying that it is saying that there are similar values for these two columns, but there are two different values. So similarly, group by, what it does, it actually categorizes or actually calculates some based upon the categories inside the columns provided to the group by clause. So similarly, so what it did, it first took the department column and categorized it according to the different values inside a department table, but it considers the same value for the time and region. We will see in the later result that the two value will also change when we have to actually get different values from these two columns. So now in the third row, what this row is saying, it is saying that in 1996, in the central region, so in the central region with null department, we have a profit of 1,49,000. So this line is saying that in year 96, in central region, the profit of all the departments, when we do not have any department inside here, it means that we are considering all the departments inside department. So the profit for all the departments in central region in 1996. Now, if we take a look at the department name column, we already said that we have only two departments. So if we have only two departments, so if we take a look at the profit of the two departments above and we sum them, so it will sum up to this value. So it is saying that so the two departments in the central region in 1996 has a profit of this amount. So now if we do not apply the cube, this row will never come. This row will never come. So the cube is actually calculating the sums according to each column inside our result set. So the cube will, so this row is again saying that in year 1996 in central region, in all departments we got this number of profit, this value of profit. Now in our fourth result set, sorry, in our fourth row, the result is saying that in year 1996 in east region. Now we have discussed about, so in these three rows we talked about the central region and we talked about different departments in the central region. We took at the different profits of the different departments in central region. Now in these three rows we will discuss about the region east, and we will discuss about the profit of each department inside east region in year 1996. So in 1996 in east region, video rental department got this number of profit. In year 1996 again in east region, video sales department had this number of profit. And similarly in year 1996 in east region, this department with the values with all the values with all the departments we got this number of profit. So if we take a look at again on above two sales values or profit values, these two profit values sum up to this value. So again if we take again take a look at the seventh row, now 7 to 9 row are considering west department and all the departments inside west and all the sales according to these departments. So similarly This seventh row is taking the west region, and it is taking video rental department, and it is saying that this department got this number of results. And similarly, 1996 video sales department has this number of values, see this number of profit in department sales. And similarly in west, in all the departments we got this number of profit. Now the 10th row is important. What is saying that in 1996 in null regions, in null departments, we got this number of profit. So the meaning of this line is, in year 1996 in all the regions and in all the departments inside all the regions, we got this number of profit. Similarly saying that we do not need to talk about the region and department. We are actually saying that in 1996, so in 1996 we got this number of we have this number of profit that we have actually earned from our company. Similarly, simply we can say that. So if we sum up this value, and we sum up this value, and we sum up this value, we come to this number. So this number is saying that in 1996 we got this number of profit from central region. This line is saying that we got this number of profit in east region, and this line is saying that we got, actually this number is showing that we got profit from west region in 1996. So if we sum up these three profits that we got from central region, east region and west region, we come to this number. It is saying that the total profit we have earned in 1996 is this value. Now the similar thing will repeat for 1997 for central region, and in central region for all the departments. If we take a look at the last row, it is again calculating for 1997 for central region for video rental department, and similarly for central region 1997 video sale department, and similarly central region whole profit, similarly for east and for west. Now, and this line again, it is showing that in 1997 we got this number of profit. So at this line we are saying that in 1997 we got this number of profit, and at this line we are saying that in 1996 we got this number of profit. And the last row, what is saying that in not any years, in null years, in null region and in null department, we got total this number of profit. So it is saying that, so this line is saying that till the time begins our company started, we got this number of, we have this number is showing that this number is our total profit from the beginning of our business. So if we can sum up this value and if we sum up this value, we can see that we come up to this result. So this result was actually calculated in 1997. So this profit was in 1997 and this profit was in 1996. If we sum up these two profits, we come up to this value. So using cubes, we do not need to actually write separate statements to calculate actually all kind of results that we are actually getting from this cube statement. So if we do not use cube statements, we will not get this kind of row, we will not get this kind of row, and similarly we will not get this kind of row also. So group by simply what it does is actually take separate values from different columns and actually try to aggregate the results based upon these values. It do not consider the different approaches when we do not have any values. It will not calculate any results. So the cube, what it does, it actually to take a look at all the possible combinations of all the columns from all the hierarchies, and it calculates all the aggregates that we need in our result set. So the cube facilitates us, and it does not it facilitates us because we do not need to write any different separate SQL statement calculate actually separate aggregate results that we did in our lecture 15 when we wrote different SQL statement to get different results from each year or from along different dimensions. So if we are using 3 dimensions here, we can actually we are actually getting the result using these 3 dimensions and using different combination of these 3 dimensions. So we can actually increase our number of dimensions. Now we simply use cube to actually get all the results or all the possible aggregates from this from the dimension the fact table using the cube clause.